Welcome to Forest.chat, where we talk about individual endeavour in Western Australia, what it takes, what it means, and how you do it. I'm your host, Paul Vandermeer, and in today's episode, we're talking with Kurt Krispyn about being a marine scientist and science communicator. Kurt has spent almost a decade as a marine scientist with study and more recently as a science communicator. Welcome to Forest.chat, Kurt.
Thanks, Paul. Very excited to be here.
Great to have you on the show, Kurt. Kurt, what actually is a marine scientist and science communicator?
It's a broad question, but I like it because I feel like almost anyone can be a marine scientist. Like there is the qualifications. So if you go to university, you get your degree and you're learning about the scientific method and different ways of research and all that. But I feel like anyone can practice a scientific method in a way. You have a theory, you can test the theory, and then quantitatively look at it and put it together. It's a hard one to say. That's probably not quite what a marine scientist is, because you've got to do obviously 3 to 4 years of training, and there's a lot that you learn in that period of time. But then when you can start practicing that sort of area and then learning about your environment, and in this case, the marine environment, I think that part of it is like a very beneficial area to what you can do for society. You can do and keep our environments in good health. And I don't want to say something that like limits that, oh no, you have to go do this to be a part of saving, conserving our environment. I feel like anyone can be a part of that. I'm not a big fan of like putting titles on things because you can be very boxed in to an area, and I feel a lot of the time there's a lot of very, very smart and adequate people that because of a certain title, they get put in an area where they could be contributing better in something else. And then in a science communicator, it's the exact same thing. Anyone can be a science communicator. Like as long as you're checking the information is correct. So the reason why people or scientists publish their work, what a published paper is, that it's peer reviewed. It's reviewed by independent people to make sure your work is correct. These aren't peer reviewed people that are on Facebook that are talking about, oh, I spoke to this person and they said this. That's not peer reviewed. These people are independently looking at your scientific method, the rigor, your information, where you're drawing on these conclusions. That is so important in our delivery or in terms of how we can understand a certain problem or solution. When someone's a science communicator, they have to put that into ways that anyone can understand. So, the term layman's terms. If I'm talking about a subject, I'm reading a lot of different papers, and then the hardest job is then how to turn that information into a way that I can tell a young person what is happening or what they're seeing or what this is. That is, I would say, the role of a science communicator. You want to convert this information out to the broader public, because when people understand something, they care. And when they care, that's when change follows from that. And I think that's a very important message.
You say communicator. What does that look like in practice?
And that can come in many forms. I know a lot of people that are science communicators, and some, they create artwork. If it's an art representation that has a meaning and a message behind it, that is a form of science communication. For me, science communication is I love to create videos, podcasts, and that's the way I sort of like to deliver. Like I love to delve into the research. So the last video I created, I read, I think around 15 different scientific papers and reports to get this information. And then I wrote a script of the important points that I wanted to get through, put it in a way that sort of flows, and turned it into words that everyone can understand. And then I matched it up with footage or stuff that I've filmed over the past, and I created a short film. And that was more of a social media post. We've done the same with documentaries, where we sort of go around the same route of doing things, whether it's something that I've sort of created and scripted together, to where instead maybe I've gone and interviewed different people that have different views on a subject, or different ways, whether it's a cultural view, whether that's a different type of science view to someone else that's saying something, and then sort of, draw them together to then a podcast where we've get to sit down like what we're doing now and have a conversation and really talk about a whole bunch of problems. So the way I've sort of gone about my science communication, I call it like the funnel effect, which is you got your social media parts. Everyone's got social media. You can create 30-second to a minute and a half sort of videos that gets out to a big, broad audience. You try to capture them to get engaged and understand something. Then if they want to learn more, they can watch the short film or the documentary that we've created. And then the people that are also quite engaged, and they can learn more by listening to our podcast. And I've kept my podcast not just environmentally based. I've spoken to all different scientists, whether that's from pediatricians to astrophysicists to chemists to different environmentalists, marine biologists in specific areas. And one of the interesting things and the reasons I love doing that is that because one, they are all connected, but when people have an understanding of something, they might not find it interesting at that moment, but when they find an understanding of something else, if something comes up, they're more receptive to a different change and they understand why something is happening or what means what. And yeah, going back to the thing I said earlier is when people understand or care about something, change follows from that. And there's a connection when something just seems like, oh, that's so abrupt. Why are they doing that? Yeah, of course you're going to have a negative feeling to why that's happening. But if you go, oh, that's happening because of this, now it's like, yeah, no, that needs to happen in that area. And then that's an area that I think has really lacked between science and different government policies or decisions that have come in, is that communication of why something has happened.
Communication is key, isn't it?
It is. It is, especially if it's something that is deciding a change or for the masses of people. We're all impacted by what happens, and if you don't convert why certain things are happening, it can sometimes create a negative effect. People may not respond in the correct way, and everyone wants to conserve the environment in a way. I don't believe I think there's a very few amount of people that are, evil-minded. I think nearly everybody wants to be able to do what they're doing for generations. And it's just when they don't understand why something's there, that's where it gets complicated.
If there's no understanding, you've got no hope in getting any sort of message across.
Mm.
How do these projects come about, like the studies that you do?
Oh, all different ways. The easiest way is that where a lot of these projects come from now is that there's a problem or something's happening, and they need to figure out the impact of what's going to happen. That's generally a lot of the time where the money for projects sort of come from. Otherwise, it's sort of from monitoring, whether if there's a marine park, the government has an obligation to monitor that. If there's, you have to conserve sort of areas. It's a lot harder, which I've sort of found for myself, is when you come up with an idea that you're like, oh, this is very important. We should know about this. Yeah, a lot of the time funding's already been put into a budget from somewhere. And so to get those kind of projects, those passion projects off the ground are quite hard. So a lot of the time what we have done is, we've done a certain job where we've been paid at a certain rate, then there's a little bit of a slush fund after that, and that can help fund us to do our passion projects, which a lot of the time it pays for maybe the food for a field trip or the food and fuel, maybe some accommodation, and then your time is you put in kind because, as we don't do this because we get paid well. We don't, it's just, as a scientist, it's impossible. We do this because you're so passionate and you love what you do. So, in a way, your hobby becomes your life and your job. It all blends into one, which sometimes can be a bit dangerous in the mental health space. But you do it because you love it. And for me, one of the favorite projects of mine is I got to explore the whole South Coast. Like my job it was a passion project of mine, and that we had to sort of what's the right word? I say discovered, but they were already there. But we sort of, in a way, discovered all these estuaries. We've gone from what we thought was 50 estuaries along our South Coast now to 155. And I found that through going through satellite imagery and everything that met the definition of an estuary, which for those people who don't know what an estuary is, it is essentially where the river meets the ocean, or well-defined creek or river meets the ocean. And it's that ecosystem that's in between those. So for people in Perth, you've got your Swan River. People down in Australind and Bunbury, that's the Leschenault estuary. The Blackwood River, they're your sort of major ones. But there's anything that sort of looks like where there's a creek, river, and if it can connect to the ocean, you have an estuarine environment there, which is generally water that is brackish between salt water and fresh water. Sometimes they can get extremely hypersaline. Sometimes they're towards the more fresher side due to a whole bunch of other different variables, which I won't go into at the moment. But that project got me to explore all these areas, and a lot of these areas that were where they were not discovered were areas that had no roads, or they were really, really hard four-wheel drive fishing tracks. And so we got to, my job was to go through there. So we're four-wheel driving, camping on all these amazing places, and hiking to get to these creeks to ground truth them. So from what I saw from the satellite imagery, then I had to go there and see it with my own eyes to sort of ground truth and check what I was seeing from satellite. Because even though there's sometimes a lot of satellite images, some of these areas, there's only, one image in the last 3 decades that are there. So, and because of like whether it was cloud cover or whatever, so you can't actually always see what was actually underneath. But so that projects like that were amazing. And then I got to go see what was living in them, and that there's all these discoveries that can still happen, that are still happening to this day. There was a friend of mine that worked on a new discovered species of whale. And like you would think by now we would know all the species of whales out there because they're such a big animal. I found a new species of fish, and I'm sure there's in our lab we've found multiple species of new invertebrates and different types of crabs and all that are in our environment. And the fact that we still have all these areas that we don't know what lives there is pretty remarkable. Like it's there's a lot shown on television or on YouTube of a lot of other scientists or discoverers or finding and all these things, but there's still so much we don't know and so much to learn and so much to be out there, which is, for me, it's just so exciting because we get to go to these areas and you go, I don't know what's there. What are we going to find? And that's just the beauty of the nature that we still have here, and the reason why we should conserve a lot of these areas before we just start destroying them, because we actually, I might jump into, if you don't mind, a different sort of story that I think quite is important. So along that journey that I was just talking about, we came across the saltiest estuary on Earth, which we didn't know at the time. But when we were there, this estuary, which has been researched, I think, almost 2 decades earlier or 16 years earlier, there was lots of fish in this estuary. When we were there, it was like just a big salt lake. It was, the salinity in that estuary was 345 parts per thousand. And for context, seawater is 35, fresh water is 0. So this was 10 times saltier than the ocean, like extremely salty. There was only one algae cell that was able to live in that estuary. But the bit that was interesting, because it definitely looked very spectacular. It made it on ABC. It was promoted all over. It's like, oh, pink estuary, like incredible. It did look scenic. But the sad part was it lost the function of what an estuary is. So an estuary cycles all these nutrients. It is a nursery for a lot of fish and other insects. And when we were there, it lost those functions. And it wasn't just that they had no now fish or invertebrates living in the estuary. It was actually everything around. So most of your insects that, they're one of the bases of the food web or food chains is, a lot of them have an aquatic life phase. So they weren't able to breed in this aquatic area. And so it wasn't just that when we were there that the animals inside the estuary were gone. It was actually, there was no insects, there was no birds. Like the whole environment, everything was just desolate. It was like you've walked into a ghost town, because you're in this environment where you expect to see possums and birds and lizards and whatever other marsupials or kangaroos even around. It was just nothing was there. There were spiders. Don't know what the spiders were eating, but I did see spiders. But there was nothing else. And even though it was quite scenic, the animal life there was gone. And that was quite an important and impactful moment that I got to see and start learning and understanding the environment. Like yes, it looked pretty, but the function of what the environment has was gone, and everything that was lost from that. And you wouldn't know that unless you knew what could have been there beforehand.
That's pretty devastating to see. Think of the Dead Sea as an example of that. Which that's hypersaline as well, isn't it?
Yeah, and that is, I think, 350 parts per thousand. So essentially the same.
Devastating to all the things that rely on it.
Yeah, it is. I can say though, it has opened to the ocean since then, and water has come down. And then I did go down there a few years later, and we did see a lot of birds and other life come back to the area. But these are like warning signs, because this got to a state that has never been recorded before for this estuary. And we actually published a paper that looked at alternative stable states, which I won't get into the too technical details of that, but essentially is that this turned from the estuarine state to a salt lake state. And then when it switched back to an estuarine state, yes, animals did return, but not all the animals returned. There was a loss of animals that were completely eliminated from these ecosystems, which is not good, because if it happens again, you lose more and you lose more. And then when you start losing these animals, you start losing the function of what the estuary does. And certain animals, like, they're not just food and prey for other animals. A lot of animals have different roles in an ecosystem. One of the more important ones is bioturbators. The bugs or fish can even be bioturbators, or birds, where they're digging up the sediment, that puts oxygen back into the sediment for different bugs that then eat and cycle the nutrients. As I was going on earlier about how everything is connected, when you start losing these roles, then everything else starts falling apart. And this is something that we're seeing in a lot of different ecosystems and environment. And actually, then switching into the science communication, something that I found speaking to different scientists, I did this amazing podcast with these pediatricians that essentially found a cure for sepsis in neonatal babies. And what they used was coconut oil, but it was coconut oil from a certain area. And when they tried different areas, it didn't quite work as well. And then during that period, I was like, it's the microbiome that's in the soil. I did a podcast with a microbiome specialist and talked about how plants uptake the nutrients from what's actually in the soil, which is the microbiome, the different bugs, essentially, I guess, it's a strange way and things that live in the soil, right? And how they find different ways to take up different nutrients and minerals that go up into the plant. And then the plant has different properties, I guess, is the way to explain that. And I was like, oh, that's, connected to this, and it's connected to this. And then, like, drawing on those parts, you're like, wow, we've just connected environmental science to pediatricians that are curing something in sepsis in neonatal babies. Like, there's those types of connections, which, being able to then draw onto just doing that as a science communicator. And then when I've gone into different areas and learned about heat waves and cyclones going through coral reefs, to then talking about why sharks are important for your coral reefs. So why are sharks important for corals, right? They're truly, corals are sedentary. Sharks don't eat coral, but why are they important? Like, drawing on that connection, it's like, it seems quite vast, right, to begin with. But then you go, well, sharks monitor the health of corals by feeding on the fish that eat the corals. And when corals are under stress, and from different types of whether through heat, we got a heat wave coming down, they're under a lot of stress to maintain the amount of energy produced by the zooxanthellae, like the little algae things that live inside the coral, because obviously they can produce a lot more energy because it's warmer, it's more temperature, too much that they can, they're under a lot of stress. But then they're also, if you don't have the sharks to monitor the fish that are eating the corals, then they're under even more stress because there's more fish that are trying to eat them and they're trying to reduce the impact. So sharks actually help corals, but it's a connection like that. So these discussions that I find really important, be able to connect how everything is together. And that's, I think, the most important thing about science communication is getting out that information and understanding, because, sometimes we draw too short a conclusion from not enough information, and wrong decisions are made, or decisions are made and we don't understand why.
Another example of that would be probably something like the cane toad scenario out of Queensland.
Mm.
It was brought in to do a particular job, and I don't think it even did that job, but it went on to do way more.
Oh, there's multiple cases. Humans throughout history are absolutely horrendous with that. Like the foxes, for example, exactly the same thing. We brought them in to do a job. They didn't do that. The mosquito fish, we brought them into the mosquitoes, and they don't even eat the mosquito. Well, they eat very little amount of mosquito larvae, but they cause havoc through a lot of other juvenile fishes in our, freshwater and estuarine systems. One of the ones I learned on the podcast was talking about kookaburras. They were introduced over to WA purely for the fact because they wanted to increase eastern states people to come over and live in WA, and so they used trying to create the soundscapes from over east over here to make it feel more like home. And kookaburras, because our wildlife and fauna in WA have not evolved to have kookaburras as a predator. Kookaburras that come over and just cause havoc. They can wipe out, everyone loves the blue wren, for example. They can wipe out the whole blue wren sort of and population in an area very quickly. That's, no one sort of thinks about that. Everyone loves the kookaburra. And it's not till we understand, that doing these things can cause impact. Cats is, the biggest one. That's one of our biggest problems. One of the only animals that's a reason, apart from us, that have caused other animals to go extinct. Yeah, my sister has a pet cat. I love this pet cat. It's a great, great pet. But if you let it go outside, well, it's going to go and cause a lot of damage. And in Western Australia, we're still very lucky to be in like big suburban areas or cities and still have a lot of native wildlife living around. Like if you go to Bangkok, for example, you're not going to be seeing that much native wildlife around there. But we're still lucky that what we have here. There's a lot of homes in where you are in Australia, in Bunbury, where they have quinders or kangaroos on their front lawn, and
right on our front lawn.
Yeah, exactly. We're so lucky to have that for where we live, that I guess once we start understanding what sort of, not trying to preach too much, but
it's the interactions, isn't it? It's the interactions between all those elements within the environment. That's a delicate balance that can very easily be upset.
Exactly. But we can still have and do a lot of the things we love doing. We just got to do it in a moderation and a sustainable way. Even going another tangent now, going like, my whole life I've grown up hunting and fishing. From a very young age, growing up on a farm on the south coast. My whole childhood was either trapping rabbits or going out catching kangaroos or whatever it was back then. And that's where a lot of my passion and love for the environment, because I just spend time whether fishing, diving, all that there. It's not something that I never want to stop doing either. It's part of who I am and where my passion has come from, but doing it in a more sustainable way that allows me to do it forever, and in a way that hopefully everyone could do it in a way that's sustainable, and that we can do this forever and teach our kids, and our kids can teach their kids. And it's a great way for people to be involved into the environment as well. I think we just got to not take things for granted and show respect and appreciation for what we have.
Mankind puts a lot of pressure on the environment, especially where we have a growing population like we have in Australia. When I was young in Perth, there was like 1.2 million people, and now we've ticked over 3 million people. And you can see the difference on the roads, but you see also that in the spread of urbanisation into the environment.
Oh, exactly. I think Perth's the longest city in the world, which is pretty crazy to think.
Like north to south would be.
Yeah. Like Perth is, for a city, has spread wide, where a lot of cities have gone up. Perth, we don't have that many high rises. We've gone wider than more than we've gone up, which is obviously you're claiming land to spread and taking away a lot of these environments. And I think we've only just started now sort of implementing environmental planning into the expansions that we're doing. It still could be a lot better, but it's something that wasn't taken into consideration that long ago, when it is now. Well, hopefully it is at some senses. I think some people can be a bit greedy with what they're trying to do, but I think there's a lot of people that want to stand up for our environment, which is a very positive thing.
Yeah, if we don't have things like our farms and all those things that come from the environment, mostly food, then without that you can't support populations and that sort of thing. So encroaching onto that type of land is also a challenge for our society.
Oh, exactly. I think one of the messages I try and push is that all of us use technology. All of us consume a huge amount of different applications or whatever that is. We're not going to stop that as a human race. You can't stop certain mining activities. You can't, these things need to happen, farming and food and all that. They're essentials to our lives. It's about finding a way we can live harmoniously with these in a sustainable way for the future, which there is a way. It just needs to be taken into consideration, and these conversations and management plans have to be put into place for that. It's not about stopping something. It's about finding a way that we can do both. It's a bit more difficult, but it can be done.
Well, that's at least there's hope in that space. So, Kurt, what does it mean to you, your family, or the community that you're able to be a marine scientist and science communicator?
Well, it's actually, I had someone tell me this the other day, which I put it in different words, but I did a podcast with Jessica Maywig, who's one of the biggest scientists in WA, and she explained it like what we do as scientists, or whether it's science communication or conservation in different ways. It's a sense of responsibility. It's easier for me to feel like the hard work and dedication that we put into what we do, that it's our way of being connected and being responsible for what we learn to get it out there and be a part of the conservation, be part of the message. It's important because, I've been very privileged in my life to be able to experience what I have growing up on the farm, going out diving and fishing with my dad, or on the boat and friends, and surfing and being in all these environments and seeing all these amazing things. And they go, well, I've had these experiences. I've seen this amazing life. I want to conserve that. I want to see my kids. I want to see other people enjoying. I want to see the love and passion. It's a bit of a responsibility to want to conserve and show these, not show these environments, but like have those environments still there. And I think that sense of like responsibility makes it easier for when, you spend hours and days and weeks and months at a computer that might not be in these environments, and you're smashing keyboards away to just try to get this area out, and bit of a mental health benefit for doing that. But I think, it's quite a hard one to actually answer, because I can answer that in so many different ways. But I think feeling part of it has been as a responsibility has been a big part.
With the work that you do, how does it change the community?
So there's two parts to this answer, because you've got the science part and then you've got the science communicator part. So the science part is you got to do the scientific test, the scientific method. You've got your question, you test your hypothesis, you analyze it, you provide evidence, and then you get it peer reviewed, which is very important to get that peer reviewed, because then you're getting independent people to look at what you've done, how you've done it, made sure it's basically correct, and that's your most informed information that you have for that period of time till it's proven wrong. That side of science is very important. This is not science. This is like anecdotal evidence is not exactly always the most influential evidence, because you've got to have, it's got to be taking all these different variables into account. And doing that science method done correctly is very impactful, but then you got to be able to communicate that as well. So that side of it is just as important, because you can spend months on doing a science project reason, you put it out there to the world, no one sees it. What impact does that have? Almost nothing. You're hoping by chance that someone's going to come by, read it, and make a difference. Doesn't always happen. You've got to be able to communicate what you have done to a broader audience, and in different ways. You've got to know who your audience is, or you've got to communicate that in different ways. You've got to have it in a way that is going to connect to scientists and a way that's going to connect to the general public that's not going to understand the scientific lingo. And there's so many different ways to get the information out there, whether it's through news sources, it's through social media. I can have my personal opinion on a way that I find is the most way that's connected through to the broader amount of people, but that's just my opinion. And so those are the two ways to connect science to community. And actually there's one other part of it is connecting the traditional owners and using their knowledge and information. What they've done is thousands and thousands of years of knowledge and communicating and using their knowledge in the same way to build the understanding of something is very important as well. And then connecting in a way that helping them bring back ownership and custodianship of an area to conserve and look after is extremely important.
So that's effectively rolling it back to how it used to be as an environment, that type of...
That's actually an interesting question you brought up. Like that's how I would say that's how I would have looked at it a couple months ago. But from people that I've spoken to in different areas that I've sort of been involved in, we're never going to go back to what it used to be. Like I think those days are long gone. The term of like restoration, that goes, we're restoring it to what it was. We've passed that. We've changed our environment so much that we're never going to get back to that area. But it's about almost like conserving what we have and bringing it back to as close as we can to that state is essentially what the mission is. We're never going to get back to what it was. We've done way too much to go back to that, unfortunately, which is a very sad realization and completely random and not scientific at all. But one of my biggest dreams would be to go on a time machine and see what the world was like, or even locally what it was like a few hundred years ago. And I can just, every time I go somewhere and see a place, I'm like, I wonder what this was like 300 years ago, 400 years ago. And you can just imagine what things were. And there's been times where I would say I've seen what it was like, because that's obviously impossible, but I went, one of the places I did research down in Albany, and there was this estuary that's almost like a fjord, like got a very deep entrance channel to the ocean. And I did my research during COVID times where no one was allowed to go out camping. And so this area was essentially blocked off from humans for about 6 months. And I was there at the very start of COVID, and then I was able to continue, luckily enough, sampling through the COVID time. And within those 6 to 7 months of when people were knowing there, the amount of fish and like fish that people target to go fishing that came into this place was amazing. I was seeing blue grouper swimming with black brim in less than a meter of water, and two species that you don't see together. Black brim are more in freshwater or brackish environments, and blue grouper obviously in the ocean, but they were together swimming with cobbler and other different sort of marine or freshwater. I actually even saw freshwater minnows swimming with black brim and blue grouper all in the one little area, and different bigger species of fish in this place. And I went, wow, this place is amazing. And then when the restrictions got lifted, people come back, and there was a lot of people camping and fishing there. All those big target fish species that I saw in that period were gone. Not saying they're, well, for whatever reason, they were gone. And I was like, that sort of was like, oh, wow. It just sort of showed the impact quickly that we can have on it's only a small, the estuary itself is only about 1 kilometre long. But it was it was kind of eye-opening to how quickly we can have an impact on an area and change something. And then, I guess even since then, just sort of learning more about the behaviours of certain fish. Like there's fish that will live in a certain cave for years, like the harlequin fish. One of a prize target fish for a lot of recreational fishers. They will live in the same cave for years, possibly. It's even estimated that they might live there for decades. Or the one patch of reef, they might move around a little bit, but which is pretty crazy, I think. And just quickly thinking how quickly, if you remove a few of these fish from an area, they might not come back there. I wouldn't say never, but they, just those types of impacts I never thought of as I was, fishing or diving or spearfishing or anything like that till you start learning these behaviors. And then this is probably going back to talking about the science that happens and then not communicating it out there. Like, I didn't know this till I delved through multiple research papers and be like, oh, wow, I didn't know that. And, they did tests on this and then we just never made it out of, say, the scientific community.
Yeah, the scientific community seem to understand a lot more of what's going on, and it's then outside of that community where the decisions are often made, isn't it? Although there's supposed to be consultation, but the people outside the community don't always know who to ask. Like, who are the people inside that they need to ask? Yeah.
Yeah. Well, a lot of the decisions so science doesn't make decisions. Science informs, or supposedly should inform decisions. And a lot of decisions politically or unpolitically decided for whatever means that might be from. And you hope that these decisions are made with the information provided by science, but not always. And I think as scientists, because it's hard sometimes as scientists to come out because you're heavily scrutinized with whatever you say. As soon as you add the term scientist next to someone's name, it feels like a bit of an obligation that you have to be 100% correct 100% of the time. And that's what people do. So if you get something wrong, people, there's that feeling that everyone's going to jump on your back and just absolutely tear you down, which sadly it does happen with social media. And so I think sometimes a few times it can be pretty daunting to come out and say something, which that's when I see, people describing and talking about their science. It's like, amazing, kudos. Like it's so good to be able to do that because, you're putting yourself out there, and that takes a lot more guts sometimes than a lot of things. There's a lot of misinformation out there. There's a lot of people happy to come out and talk about something that has very little knowledge or evidence to state to their claims.
That's always a danger, isn't it?
Mm.
So what's next for you, Kurt? What are you up to from here?
It's been very hard to juggle doing my PhD and research plus also the science communication work that we've been doing. So I'm still doing both. I'm not saying I have stopped either, but the next few jobs that we have are sort of filming a couple documentaries, which is very exciting. So I'm going to some remote islands in a few days' time I can't speak too much about this project, unfortunately, but we're going to go film in some remote places, which is about a big science project, which is really cool. And I can't wait for that to come out because that's not my science project, but it's something where I've wanted to develop my skills and work as a science communicator in helping other scientists get their messages out to the world. And so being able to be a part of something like that is like, I'm extremely excited because it's now becoming something a lot bigger than I've sort of ever expected to what I was going to be involved in. And that's something like, hopefully be able to drive some real change and some real impact, which is very exciting. So those are probably my next steps, is just continuing doing those things like that. The podcast I run is a fortnightly basis. So those messages out there, and I've got some great episodes I've already recorded, lined up. And then hopefully you can delve into my PhD research, which is on the estuarine ecology of estuaries in the southwest WA. So that's trying to do, I guess, a bit of research, and I'd say all 155 of them, but it's like some bits is just measuring some stuff from satellite imagery, but some I actually get to go to and find out what's living inside them.
That sounds like it's the favourite part for you.
There's nothing better than being out there, that's for sure.
Kurt, if somebody wanted to be a marine scientist or science communicator, how would they go about it? What would they need to do?
This is a great question, because I want to answer this by saying that you don't need a degree to be a part of these things. There's so many amounts of, and then hopefully going to be more and more opportunities in citizen science projects where you get to work alongside scientists and be involved with different projects. I wish I had more opportunities to take people along with me. Some science projects that you, as I mentioned earlier, the occupational health and safety restricts who you can take out, but there's still so many different programs where you can be involved and see what's happening and learn. I think that's the biggest thing. But filmed a documentary with Bush Blitz and the Walpole National Park and peatlands in the southwest, where they have a massive citizen science project, which I think is actually the biggest in Australia. And there was like 250 people. My mum included came down, and she's not a scientist by any means, but she was so involved with different things like that. So there's ways that you don't have to have the qualifications to be involved. But if you're a young budding student looking to get into science, I think this is sort of a message for everyone, is follow your passion. If you love something, you just do it. You'll find a path for you. I was a terrible student at school. I was heavily into my football. I played a lot of footy growing up in the development squads and academies. So I spent a lot of time away from school. Not saying that was the reason I was bad at school, but it was definitely a reason. But my concentration, ADHD, and just sort of, if it wasn't something I was interested in, I had no interest in it at all. And so that reflected in my grades. And I was told that I couldn't go to university to begin with. But my passion, as I mentioned, was like, as a 4 or 5 year old child, my only reading book I ever read was the fish identification book. And then so my passion was fish and the marine environment. And then once I was able to delve into that area, it was not hard to concentrate at all. I just got transfixed, and I was able to sit and do 15, 16-hour days at a computer and delve in. Not saying that you need to do that to become a marine scientist, but when you find your passion, it's like a drug. You just find happiness within that. And I think for anyone, it's like, you don't need to know what your passion is. You just got to keep trying new things, and then you just find an interest in an area eventually. Whatever, it doesn't have to be marine science, doesn't have to be environmental science, could be geology, which I guess is environmental, but like it could be anything. But when you find your passion, I think you're a much happier person.
It's quite amazing that being interested in something and getting to do it, and how it drives you along to do more and more in the same space. And it's engaging, and nobody else actually has to push you along to do anything. You're actually actively out there taking it on.
Yeah, exactly. Like the amount of fights I had with my parents to try and get me to do homework, or even, the school meetings where I had so many after school detentions because I just didn't do my work and just couldn't concentrate. I had just no interest at school.
And it was nothing to do with your capability. It was all to do with the lack of connection between what they were trying to put through and what you were interested in.
Yeah, exactly. My parents actually, to put it for example, I was so bad at school. My parents actually took me to Kit McGrath, which was like an education service for people that struggled to learn in an area, or struggled to learn. And they took me there, and then I did a few tests. And when I was there, I was like, I really don't want to go here. So whatever test they ran, I tried hard. And then they told my parents, he's got no learning disability, which really they didn't pick up on the ADHD then, but he's just lazy, which was, a wrong way of how they came to that analysis. But essentially that's what it was. It's just my passion. They didn't excite me from what it was. And, when I went to uni, and my boss gave me the opportunity to research in an area that I loved. Actually, when he showed me estuaries, like when I went to university, I was like, I want to go to the deep ocean. I want to learn what's out in thousands of meters of water. And because I thought that was the most like untouched, pristine, exploratory, because I always wanted to be an explorer area. And then he showed me estuaries, and the first project was actually an estuary that I lived on. I was living in Dunsborough on Toby's Inlet at the time in a real shack, and did a lot of fishing. And in that little estuary, people might think it's a river, I guess, but that little estuary there. And he took me out, and it was about 2 weeks of work in this system, and I just fell in love with estuaries. And then he offered me a project that allowed me to go explore the south coast, and I went, this is amazing. I'm literally going out camping with my friends and finding out what lives in these environments that we have no idea about. And that's where we found a new species of fish, and go on all these 4-wheel driving, and we were camping in thunderstorms and rain where all our swags are wet, and having to go through all these things like, snapped axles on my car and all these different things, which was just like that side of, it's not quite like the science side. Well, I guess it's part of science because shit happens, right? But like I was like, this is incredible. And then that's where my passion sort of for estuaries come up. Kind of lost where I was actually going before this. I just started rambling about a random story. But yeah, having that passion and that seeing those things and trying something new was definitely an amazing experience that sort of led to. Oh, I actually remember now. Yeah, when I was able to do that and really dig into the science, I got one of the highest scores given to an honours student at the university, which is in a way is like gone from a high school student that was told couldn't go to university because of bad grades to then getting one of the highest scores at university. It's just it goes to show that if you follow your passion and you do what you love, you can do some pretty incredible things.
I agree. And I also agree that in a lot of cases, boys should not be going to schools in the format that they are these days.
Well, yeah, I think boys and girls, though, there's a lot of, I think girls, they mature a lot earlier with their brain so they can, they can handle what's sort of been told to do at school at a younger age because they're just more mature. But yeah, this is just sort of getting down to school format. But I think school should find ways to excite students, and it is changing. It's definitely changed from what I was there, and I don't exactly know what it's like now. Actually, I do know a little bit because I get to go to schools and see all these new opportunities, which wasn't happening when I was young, and they're bringing in all these different experiences and learning from people, and we get to do some cool school talks. Like I'm doing another live show where we did I don't know if you saw this actually, but we did the world's first live underwater podcast earlier in this year, where it was underwater live streaming with Associate Professor Mike Van Coolen, and we aligned what we talked about to the school curriculum, and that was streamed to at least 15 different schools around Australia. I'm doing another live show later in the year, so this is a little bit of a sneaky drop because we haven't announced it yet properly, but I'm doing another one later, and we're hoping to get even more schools involved. Actually, we're doing two live shows by the end of the year. There's 2 lined up, which would be really cool. So I think showing those parts can really inspire people. And this is sort of actually my whole big philosophy for everything I do is that change happens from inspiration, not from instruction. And it's not just inspiring young kids. It's in everybody. And that's the messages I always try and push. Like if you go through any of my videos that I've created, there's not one video that is telling someone to do something. It's all about showing what's there and inspiring to want to learn and love and understand something. And then they can make up their decisions themselves.
That's a very good thing to be doing. I'm really impressed to hear that, Kurt.
Thank you. Been a lot of fun. A lot of hard work, but it was like when you're following and doing something that you love and you passion, those long nights and long days, and it's rewarding, and you love what you do and you become a happy person because of that. And I think if you asked me this a couple of years ago, I wasn't doing what I was doing now. I was doing research, but that's kind of all I was doing. I was just like doing the research part, and then my passion for the science communication, when I was able to really follow that and try that, even when it wasn't, no one was really seeing it or watching it already, but like I was so much happier when I was doing that. And that's part of one of the learnings I found is when you follow your passion and you're doing what you love doing, no matter what that is, you're a much happier person.
Thank you very much, Kurt, for being on Forest.chat, and all Forest.chat listeners wish you the best with your future endeavours, especially those tricky live underwater live streams.
Yes. Yeah, thank you. If anyone wants to tune in, paramount importance is my science communication channels.
We'll put a link to that in the show notes.
Awesome. Thanks, Paul. This has been great talking to you.
And you, Kurt, thank you. You've been listening to Forest.chat, where we talk about individual endeavour in Western Australia, what it takes, what it means, and how you do it. I'm your host, Paul Vandermeer, and in today's episode we've been talking with Kurt Krispyn about being a marine scientist and science communicator. Remember, there are 4 ways to get involved with Forest.chat. Share the domain Forest.chat with your friends and family and people you meet. When you sign up for emails, you get advance notice of episodes. Listen to the episodes at forest.chat/episodes. If you do something interesting or somebody else may find interesting, book an interview at forest.chat/interviews. If you want to support a small business, book an advert at forest.chat/advert. I'm looking forward to joining you with our next guest. Until then, enjoy making it happen.